Good morning, students. My name is Kriti Mishra, Assistant Professor, Akgec. Our today's topic is data visualization. So, what do you mean by visualization? Visualization is kind of visualizing data, means representing data in a paragraph form or in the written words, are as comparison to that the much easier way to represent data and understand data in the visualized way in the data interpretation format. So, let us start. We will study data visualization and overall perspective. So, the first topic is aggregation in data visualization. So, what is data visualization? Data visualization is a way of representing data, pictorial representation of data. So, aggregation in data visualization. How we aggregate data? By using different mathematical formulas like sum, max, min, count, etc. So, aggregation in data visualization refers to the process of summarizing or combining data to make it more meaningful so that the person can understand it easily and easier to interpret in a visual format. It involves grouping data points and applying mathematical or statistical operations such as sum, average, count, min, max, etc. Now, the simplification is it reduces the large data set. It simplifies the data. As I said, it simplifies the data. It reduces the large data set into concise summaries, making trends and patterns clearly. Trend analysis. Aggregating by time intervals like daily, weekly, etc. help in identifying trends over time. Comparison enable side-by-side comparison of summarizing category. Then focuses. It help in highlighting key insights without overwhelming details. Next. Some of the common examples are bar chart, line chart and pie chart. These are the common examples. Like you must have seen in the sports, for example, sports analysis. Like when we see the match, there is a pictorial representation of data. Like what is the score, etc. Regarding the weather, etc. What is the pitch current status and how it will go. So these all are the pictorial representation of data. And another example is like the elections. In the elections result, you must have seen these kind of graphs in the news channels that this particular party scored this much or this scored this much. So these are the examples of pie chart. Likewise, line chart. For example, continuously collecting and analyzing updates of hospitals, alert on regions with snowfalls and identifying hospitals with large shortfalls. These are the examples like pie chart, the way it represents. This is the pie chart, this is the bar chart, tab diagram, pictograph, scattered plot, time series, area chart, bubble graph. This is called the line chart, radar chart, venue diagram and heat map. These all are the representation of data which make the work easier so that the higher level of officials can easily understand the data and take the respective decisions. Next. Now we will discuss about OLAP, online analytical processing. So what is online analytical processing? It is a system-enabled interactive analysis of multidimensional data for decision making. Different type of OLAP implementation to specific performance, storage and scalability needs. The first is Relational OLAP. Relational OLAP. What is Relational OLAP? User relational database to store data in tabular format, for example rows and columns. Features: data is stored in relational tables and queries are executed using SQL. Suitable for large data set with complex query. Support dynamic and detailed analysis, but may have slower query performance due to the frequent database reads. What are the advantages? Advantages are handle large volume of data. It can leverage existing relational database infrastructure, scalability with robust database optimization. And what are the disadvantages? It slower the query performance compared to MOLAP. And what is MOLAP? MOLAP is multidimensional OLAP. It depends on the database schema and indexing for efficiency. Next. Now we'll study about MOLAP. MOLAP is, as I have said, multidimensional OLAP. So what is the definition? It stores data in pre-aggregated and multidimensional cubes for faster query performance. What are the features? Data is organized into multidimensional array or cubes. Ideal for fast data retrieval, especially for aggregate matrices. Limited to moderate data volume due to cube size constraints. What are the advantages? Is extremely fast query response time, and pre-computed aggregation improve performance for reporting, and intuitive for users familiar with multidimensional data. And what are the disadvantages? Are less scalable for very large data set. Pre-computational, requires significant storage space and time, and updating cubes can be time consuming. So the multidimensional OLAP. So let me give a short detail about multidimensional. What is multidimensional data? Is representing data in various dimensions. This is the way of representing data in multi-dimension. Here is 3 dimensions. One is this, one is this, and one is this. For example, if we represent data about any location, so in one dimension we will see location, and then product, and then quantity or quarter. Likewise, we represent data in multi-dimensional format. Next. Now, we will discuss about OLAP. What is OLAP? OLAP is hybrid OLAP. OLAP is combination of ROLAP and MOLAP both. So, there is a relational OLAP also and multi-dimensional OLAP also. By sorting frequent access data in cubes, MOLAP, and less used data in relational database, ROLAP. What are the features? It uses MOLAP for summarizing data and ROLAP for detail or drill down queries. It balances performance and storage efficiency. What are the advantages? It offers a trade-off between storage and query performance, scalability of ROLAP with speed of MOLAP, more flexible in data analysis. And what are the disadvantages? Disadvantages are complexity. What is the disadvantage of OLAP? Is its complexity in implementing and maintenance. It may require more resources to manage hybrid storage layer. Next. Now, this is the comparison table of ROLAP, MOLAP and OLAP. So, ROLAP is relational table, MOLAP is multidimensional table, and OLAP is combination of ROLAP and MOLAP both. And what is the performance difference? ROLAP is slower for aggregated queries and MOLAP is faster for pre-aggregated queries, and OLAP is balanced performance. Scalability is highly scalable, limited by cube size, moderately scalable. When we talk about the flexibility, there is a high for a dynamic query, dynamic query limited to predefined cubes, and flexible with data, flexible with trade-offs. Storage space is efficiency for large data sets, high due to pre-aggregation, and in OLAP it's moderate. So, this is the chart difference of this ROLAP, MOLAP and OLAP. If it's asked in exam, you can write down like this. Next, we'll discuss about data mining inference. So, what is data mining inference? Data mining inference, it is a user interference or API that facilitate interaction with the data mining system. It enables users to extract patterns, insights and knowledge from large data sets efficiently. And the key feature and component of data mining interface includes data import and management, mining tools and algorithm, and visualization. What is data import and management? Support for multiple data format, for example CSV, JSON databases, etc. Data cleaning, in data cleaning there is an integration and transformation tools. Next is mining tool and algorithm, options for selecting algorithm, for example clustering, classification and regression. Next is parameters adjustment for algorithm. Now, visualization, as I have said, in visualization there are charts, graphs, heat maps for pattern analysis, tools for visualizing relationship, trend and clusters. Next is query language, integration of SQL or specialized query language for extracting subset of data. Then workflow design, drag and drop information for designing data pipelines, step-by-step guidance for mining processes. Next is model evaluation, matrices like accuracy, precision, recall and ROC curves, tools for comparing and validating models. Next is scalability and collaboration. It is the ability to handle the large data set and distributed systems. Features for sharing result and teams. What are the examples? Examples for data visualization, for example Veka. Veka is the very good tool for representing data and applying various machine learning algorithms, and Power BI and Tableau. These days Power BI and Tableau is running very fast for visualizing data more easily and comfortably, which gives more information to the user so that the person can analyze the data visualized DAX and give the respective decisions regarding the analysis. Next is inference security. What is inference security? It refers to protecting sensitive information. It refers to protecting sensitive information from being indirectly derived or inferred from accessible data, even when direct access to sensitive data is restricted, or can sometime infer these information by analyzing related data or patterns, and this is particularly related in field like machine learning, database and cyber security. So, what is the first in inference security is access control, encryption, anomaly detection, audit trail an isolation mechanism. Access control means who can access the data, who is the particular authorized personnel can access the modified sensitive data. Encryption means encrypting the data using the different code is use encryption for data in transmit and at rest to prevent unauthorized access. Now the anomaly detection. What is anomaly detection? Monitor and detect unusual activity in the data mining system that may indicate inference or breaches. Now audit trails, it maintain the logs for all activity and access for accountability and forensic purposes. Isolation mechanism, it uses sandboxing and network segmentation to isolate sensitive system for potential threats. Next is backup. For example, you must have seen in WhatsApp or in your mobile that when you install the WhatsApp, the app will ask you want to back up the data daily, weekly or monthly. Then what what do you mean by backup? Backup is if your data is lost, then you can back up your data through the particular generated backup so that the useful data or important data cannot be lost from your phone or WhatsApp. So this is a very good example of backup, and so we use backup. Why? It refers to creating a copy of data files or system to protecting them from loss, damages or corruption. Backup ensures data recovery in case of accidental deletion, for hardware failure, cyber attack or natural disasters. Regular backup, schedule automatic backup of data and configuration at regular interval. Versioning, it maintains the multiple version of the data to restore previous states if needful. Secure storage, it store backups in secure location, either non-premises or entrusted cloud service with encryption. Next is off-site backup. Keep copy of backup in geographically distant location to mitigate risk like natural disaster. Next is recovery. We have created backup, then there is a next step, that is recovery. Recovery is the process of restoring data system or operations to their original state. After a failure or disaster or security breach, effective recovery plan ensure minimal downtime, data integrity and continuity of operations. Disaster recovery plan. What is disaster recovery plan? It develops a clear plan for restoring services after disruption with defined rules and timelines. Backup verification, regularly test backup file to ensure they are intact and restorable. Next is redundancy. It uses redundant system, for example mirrored servers, to reduce downtime during recovery. Next is recovery tool, deployed tool for rapid data restoration such as database, snapshot, recovery or cloud backup solutions. Next is documentations. Documentation, it keep detailed documentation. For example, you do documentation while you make the software. Likewise, here the documentation, it keep detailed documentation on recovery procedure to streamline processes during a crisis. Next. Now, what is tuning a data warehouse? Tuning, it involves optimizing its performance to ensure efficient querying, data retrieval and overall operations. Key strategy include schema design optimization, use star or snowflakes to streamline data relationship. So what is star? Schema. What is a schema? Schema, let me give you a brief introduction about schema. schema is skeleton of database. For example, where you have stored the data, in which table, in which column, through the schema, through the metadata, you can easily know where the data is stored. And what are these are the structures in which you represent data. Star and snowflakes. In the star there is a one fact table and attached dimension table. Dimension table and dimension table. So this is the fact table and this is the dimension table which are attached. So it will form a star like structure. So it is called the star schema. For example, there is a detail of product ID, location, date, and there will be a dimension table with product ID, table containing all the detail regarding the products, and location and date or quarter, etc., or quantity. Likewise, this it will form a star like structure, so that it is called the star schema. And in this snowflakes schema, there are some more dimension table attached to these dimension tables. So it will form snowflakes schema. Use a star or snowflake schema to streamline data relationship. It optimizes fact and dimension table with appropriate indexing and partitioning. Now, indexing, it creates the bitmap index for column and low cardinality. It uses B tree indexes for high cardinality column. It avoids the over indexing to prevent overhead during data loading. Like the fact table contains these product ID, location and data, and attached table dimension table. So it contains the data regarding product ID, location and etc. So it will avoid over indexing. Why? Because your data is in structured way. When your data is in structured way, then unnecessary of over indexing is not required. Indexing is required, but over indexing is not required. Next is partitioning. Partitioning large tables based on time, range or hash to reduce the query scope. It uses partitioning pruning to access only the relevant segment of data during the queries. Next, data loading. It uses a bulk loading technique to efficiently populate the data warehouse. Disable indexes and constraint during data loading to improve speed, re-enabling them afterwards. And what is data compression? It applies columnar or low level compression to reduce storage and improve input output performance, IO performance. It uses compression features support by the database system. Next is concurrency management. What is concurrency management? Concurrent, what do you mean by concurrent? The same thing occur simultaneously. So balance workload by using the query schedule to avoid the bottleneck. Done. During the peak uses. Materialized view, pre-compute and storage. So these are materialized view and query optimization. These are the context regarding tuning the data warehouse. Students, these are the few topics which we have studied: tuning the data warehouse, recovery, backup, inference security and data visualization. So thank you so much.